the one I showed yesterday, and was talking about the future direction of the field. With this future of 2 years ago is actually nowadays research, and it's possible to build solar cell with completely different principle behind. So we can deposit the perovsite on a semiconductor, with a porous semiconductor that acts as a scaffold. We can create a PIN junction, a thin solar cell, but we can also have a bulk, well, an heterojunction PN solar cell. My research, as I said at the beginning, is in the field of DFT and ab initio calculations. So we need a view that is more radical and atomistic view. So first of all, the term perovskite refers to the name of a mineral, which is calcium titanate, and for extension, all the compounds with the same symmetry is called perovskite. So the structure is quite simple. We have a cubic lattice made of octahedra that create a cube octahedra cavity where we can host an inorganic ion usually. But actually, we were talking about hybrid perovskite. The term hybrid is used because the inorganic cation in this type of system is substituted by an organic cation. So this is another example of our flexibility we have when we approach the field perovskite, because it's possible to change the composition, the stoichiometry of this compound, and so the properties. But the reality is not that simple. In particular, we're going to talk about methylammonium iodide, that for in the interest of time we will call it MAPI. And there are three phases of MAPI. The high temperature phase, which is the cubic one, is quite simple. We have this cubic lattice, and the molecule inside can freely rotate. When we lower the temperature, we undergo a tilting of the octahedra, and we arrive to the tetragonal phase. In this phase, the molecules are still able to move, but they have some perforation direction where they want to orientate themselves. If we further rotate, further cool down the system, we go under another transition which led us to the orthorhombic phase. We have another tilting of the octahedra, a small distortion, but now the molecule is frozen. This different behavior of the molecule in different phases is quite important for reasons that we'll see later.